Good evening, all. Good evening, students. Am I audible? Can you see the screen?
Yes, sir.
Yes or no?
Yes, sir.
Oh, okay. Thank you. So we'll continue the concept placement class. My topic: permutation, combination, and probability. Permutation, combination, probability. First, we'll see that permutation. Combination in the name of combinatorics already taken. So in that, I'll take a few problems only. Other problems taken by Johnny Madam and probability. These concepts already you all studied in the second year. The probability, permutation, combination, everything. So here in the aptitude point of view, we will concentrate few problems, concepts and problems. Permutation, each of the different arrangements which can be made by taking some or all the given number of things or objects. Given number of things or objects at a time is called the permutation. Otherwise, permutation of things means arrangement of the things. The word arrangement is used if order of thing is taken into account. Thus, if order of different things changes, then the arrangement also changes. So that is the permutation from particular objects, taking a certain number of objects at a time, and arrange, selection and arrangement. Selection and arrangement is coming under permutation. So in the combination, it will consider only the selection. Okay, it will consider only the selection of the objects. Okay, whether that is first or second, that's not a matter. So it will select selection. So it will concentrate only the selection. Whether that is first or second or third, that's not a matter. That's a difference between permutation and combination. In that, we use that formula NPR. So that means R and n be the positive integers such that 1 less than or equal to r less than or equal to n. Then the number of permutation of n different things or n different objects taken or different things or objects is denoted by npr, otherwise p of n comma r. That way we can denote the permutation. So np or otherwise p of n comma r, that is equal to n factorial divided by n minus r factorial. If you are going for combination, so that is NCR, and the formula is n factorial divided by r factorial into n minus r factorial. That is the combination formula. So the only difference in the NPR, the denominator additionally r factorial will come. That is a permutation combination difference. That means permutation is selection and arrangement. That is permutation. Combination, it will concentrate only on selection. Okay, it will concentrate only on selection, selecting the object, selecting the elements, or selecting the things. That way you have to understand. So the number of permutation of n things taken all at a time, out of which p are alike or and are of one type and q are alike are of second type, rest all are of different. So in the collection of objects, some of the objects will be same. Okay, so the example is given, so you can see that. So the formula is n factorial divided by p factorial into q factorial. So p factorial, so p certain elements are alike, same group, same type. Q certain elements are same group or same type. Like that is given. In that we are picking all the elements. In that the permutation is given by n factorial divided by p factorial into q factorial. So for that example, there are 5 red, 4 white, and 3 blue marbles in a bag. They are drawn one by one and arranged in a row. They are one by one drawn, arranged in a row, assuming that all 12 marbles are drawn. Determine the number of different arrangements. Determine the different arrangements. Total in that 12 marbles are there, 5 plus 4 plus 3. Taking all at a time, I mean one by one, and arrange it. Arrange it. That is important. How many different arrangements? Arrangements relevant to the permutation. Keep in mind, arrangements relevant to the permutation. So you have to use permutation formula. In that, 5 marbles are red, 4 marbles are white, 3 marbles are ditto like blue. So for that, the different arrangements. So if all are different, simply you can put it as a 12 factorial. But here, first one PQR like that you can take. So they are mentioning it as a P1 equal to 5, P2 equal to 4, P3 equal to 5. That means P1 denote the same type of red marbles, 4 white marbles, that is P2, P3 as 3 blue marbles, same size, same color. Okay, in that meaning they are taking. So and arrange it, I mean permutation, we are going to find. So that is n factorial divided by P1 factorial into P2 factorial into P3 factorial. That is 12 factorial divided by 5 factorial into 4 factorial into 3 factorial. So for this you have to find the value. So you can do manually. So factorial means 4 factorial. 4 factorial means 4 into 3 into 2 into 1. That is the thing. Similarly for any value. So that is 12 factorial means 12 into 11 into and so on 1. And keep it in your mind, 0 factorial is equal to 1, not 0. So keep it in your mind, 0 factorial is equal to 1. 1 factorial also equal to 1. Those things you should remember. Next, the number of permutation of n different things taken are at a time when each thing may be repeated any number of times is n power r. So keep it this. This is one case in the permutation. Number of permutation of n different things taken are at a time when each thing may be repeated any number of times, that is equal to formula n power r. N power r. So for that, from the example, you can understand the definition clearly. In how many ways can 5 apples can be distributed among 4 boys? There being no restriction to the number of apples each boy may get. Okay, that means 4 boys are there. So we can take it as a B1, B2, B3, B4, like that you can take. The sharing is all 5 apples may be given to the first boy, B1. Okay, that is one kind of sharing. Okay, if all the 5 apples may be given to second person, second boy, and so on, fourth boy, like that, one sharing, one kind of sharing. Next, next one, 4 apples to the first boy, 1 apple to the second boy, remaining nil. That's also one kind of permutation. That's what the definition is given like this. So for this case, you will get how many different permutations, how many different ways you can share the apple. So here, any number can be given to the particular person. That's it. So for this, the values 4 power 5. What is it? 4 power 5. And different what is it? Combinations, different ways they can raise the question. For that case, slightly modify the permutation formula we have to use. So number of permutation of n different things taken are at a time when a particular thing is to be always included in an arrangement, or particular things should be there in the selection. So for that, the arrangement is 1 into n minus 1 p r minus 1. So one particular things, that is not r, that is actually 1. So 1 into n minus 1. Okay, out of selection or particular things, one particular objects or element should be there. So that is 1 into n minus 1 into, sorry, n minus 1 p r minus 1. So number of permutation of n different things taken r at a time, when yes particular things are to be taken always included in each arrangements. Okay, n objects, in the n objects or things, or we are going to pick in the or yes particular things or objects always there in the permutation. So that means s is less than r. Okay, something if you take it up n equal to 10, r equal to 5, s equal to something 2. So that manner for understanding I am telling. So for that, the permutation will be s factorial into r minus s minus 1 into n minus s p r minus s. N minus s p r minus s will be the formula. So particular elements. So first one is for only one element. Here some Yes, number of objects in the selection should be there. So number of permutation of n different things, one at a time. I mean, eliminate one particular object for the selection. So for that, the arrangement will be n minus 1 PR, n minus 1 PR. In the selection, you have to leave particular element or objects. That's a third case. So number of permutation of n different things taken all at a time. When m specified things always come together. So for that, the formula is m specified things. All the elements are taking, not like first three cases. The first three cases we are taking our objects. That means n less than r. So here we take all the what is that number of permutation of n different things taken all at a time. When m specified things always come together. Okay, come together. I mean, in the arrangements, while arranging it, they are always as a group. For that case, the formula is m factorial into n minus m plus 1 factorial. Okay, so that means what is that? So in the okay, so we'll see that example. Number of permutation of n different things taken all at a time. In that, m specific things never come together. N what is that? M specific things never come together. That is n factorial minus n factorial into n minus m plus 1 factorial. Yes. So in the particular word, what is that? Consonants are not together. Okay. So like that, they may raise it. For that case, you can go for these two formulas. Together, next one is uh, not together. Okay, particular objects or elements are not together. So like that, we have to take it up. So next is circular permutation. Circular permutation, arranging n different things, arranging it in the circular table or the circular form. Necklace, in that arranging the beads. There we use the circular permutation. So that is n minus 1 factorial. So there we use the formula n minus 1 factorial. So for that, the formula in how many ways? Example is there. In how many ways can 8 people can be seated at round table? So 8 people are there, all 8 are a different person. So that is direct formula 8 minus 1 factorial, 7 factorial. That is 5040 different ways they can be seated in the round table. Next, number of circular arrangements, permutation of n different things. Then clockwise and anti-clockwise arrangements are not different. Anti-clockwise and clockwise different, not considered as a different arrangement. For that case, the formula is permutation is 1 by 2 into n minus 1 factorial. 1 by 2 into n minus 1 factorial is the formula. So find the number of ways in which n different beads can be arranged to form a necklace. N different things arranged to form in a necklace. Actually, here n equal to 5 they are taking. So, okay, so that means required number of arrangement is n equal to 5. Okay, so that is 5 minus 1 factorial. So that is 1 by 2 into 4 factorial. So 12 different ways include the clockwise or anti-clockwise. Here anti-clockwise not considered. Only one kind you have to take, not both kinds. Okay. So for that case, permutation is 12 for 5 different beads arranged in the necklace. I mean round table like concepts. These are all concepts along with simple examples. Next, we will move on using this concept. We are going for the problems. So each section in the first year of +2 course has exactly 40 students. If there are 4 sections, in how many ways can a set of 4 student representative can be selected, one from each section? 4 section, 4 student representative. How many different permutation? How many different ways you can select the person? How many different ways you can select the person? So here 4 section, 4 student representative. Each section 40 students are available. So for that the explanation is given. So one student representative can be selected from the section 1 in 40 ways. because in the first section we have 40 students. Okay, 40 different ways you can select one student representative from the section 1. Next, section 2, similarly 40 different ways you can select a one student representative. Similarly for third and fourth. So when you multiply all this, these all permutation, we have to take it up. So you can take it up for student 1, S1, 1, S1, 1, S2. I mean section 1 as a, like that you can take it up and think. So this number of 40 into 40 into 40 into 40, not summation, this one is multiplication. This number of ways you can select 4 student representative. So that is 25,60,000 number of ways you can select 4 representative from 4 section with 40 students as a class strength. Each class strength as a 40. Okay, this one is direct one. There is no trick in the question. Okay, sometimes they will add up for understanding. Step by step, we'll move on. There are 6 multiple choice questions on examination. How many sequence of answers are possible? If the first 3 questions have 4 choices each, and the next 3 have each 5 each. Okay, first total 6 multiple choice questions are there. The first 6 total number of 6 questions. First 3 questions are having 4 choice. Okay, next 3 questions having 5 choices. In that, how many answer sequence? Okay, how many answer sequence? How many sequence of answers are possible? Okay, so they don't know how many different ways they can answer. So the explanation, so first 3 questions, question number 1, question number 2, question number 4, question number 5, question number 6. So first question number 1 having 4 options. So 4 different ways you can answer it. So that is 4. Next, the second question, question number 2, 4 options. So into 4. Next, question 3, that is also having 4 options. So into 4. Next, question number 5, 4 having 5 options. So 5 different ways you can answer it. So that is 5. Next, question number 5 also having 5 options. So into 5. Next, sixth question also 5 options. So into 5. So that is 4 into 4 into 4, 64 into 125. So total 8,000. 8,000 possible number of ways so they can answer it. The answer sequence. The answer sequence means one of the sequence. First question, answer A. First answer. Question number 1, answer A. Question number B, answer A. Like that, all the questions you can take it up as a first multiple choice as an answer. So that is one of the sequence. Okay, A. In that total 6 A's as a one of the sequence of answers. Okay, next sequence. I change only second, last question option as a B. Okay, B. So remaining all A. This is a different sequence. That is A. Last one B. So that is one of the option. Next, one more. So all first 5 questions answer A. Last question answer C. This is another answer sequence. In that manner, you can create the answer sequence will be 8,000 number of possibilities are there. That is the meaning. Okay, so understand the question properly. So how many numbers are there between 100 to 1000 in which all the digits are distinct? So 3-digit numbers. In that 3-digit numbers, what is that? Digits are distinct. So for example, how come it is coming? So that is 100. So that is 0 is coming. So it should not be counted. So if you take it up 101. So the 101, 1 is coming twice. So the 101 also eliminated. That will not come to our this counting. So next to 103, yes, 103 will come. So that manner, how many such number exist? 3-digit numbers are where all the digits are distinct from 100 to 1000. Okay, 3-digit numbers. So here the 3-digit numbers, 100th digit, 10th digit, unit digit. These things are there. So the explanation is given. So in the possible numbers, totally 10 digits are available. So there is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the 100th digit, except 0, we can fix it. If you put 0, it's become as a 2-digit number. It will become as a 2-digit number. So in the 100th digit, 9 different ways you can fix the 100th digit number. Okay, so now remaining how many numbers will be there? Remaining again 9 numbers will be there. Include 0. Okay, so out of 10 digits, we consider from 1, 2, 3, 4, 5, 6, 7, 8, 9. Only these 9 numbers, 9 digits, we can use it for the 100th digit. Please do understand, do follow. So that is 9 different ways you can fix, arrange the 100th digit. So in the 10th digit, remaining 10 numbers. If you take it up, the 100th digit as a 1, remaining how many numbers, how many digits will be there? 0, 2, 3, 4, and so on, 9. So 9 numbers will be there. So that's why they have put as a second or as a 9. So after fixing these two numbers, okay, two numbers in the 100th and 10th digit, remaining 8 possible digits are available that can be filled in the unit digits. So hence 9 into 9 into 8. So such a numbers digits are available in 100 to 1000. So that is 648 such numbers are there. In the 648 numbers, all digits are distinct. I mean 100th digit, 10th position and unit position. You can check it. Such a numbers exist. Otherwise, you can okay, one by one you can check like 100 to 1000. Write the number, put the tick mark. How many such number exist? That you try it. Okay, so for this extension, one more problem. The number lock on a suitcase has 3 wheels. Number lock, okay, what is it? 3 wheels, each labeled with 10 digits from 0 to 9. Okay, so you all know well-known concept. 3 wheels, okay, number lock. 3 wheels will be there to change the numbers. So total, what is that? 10 digits. 0, 1, 2, 3, 4, and so on, 9 digits. For opening of the lock is particular sequence of 3 digits. What is that? 3-digit number. Okay, 3-digit number. But what is that? First digit can be 0. Okay, first digit can be 0. Okay, 0, 1, 2 as a sequence possible for the number lock. Okay, so include what is that? No repeat, but in the 100th digit. Okay, so it's not in the meaning of number. So like password, ATM password, like that you all think. So the first digit, okay, first digit, 10 different ways you can fix it. Next, second digit and the middle code, middle wheel code number, that is remaining numbers. Okay, remaining 9 numbers, we can fix it. Next, third place, that one is 8. So here condition is given, the number lock, what is that? The digits are not repeats. Okay, in the 3 digits with no repeats. With no repeats. So how many such a sequence will be possible? So in that 100th digit can be 0 also possible. So that is 10 into 9 into 8 is the multiplication. Okay. So it's not 9 into 9 into 8. So the previous problem's corresponding application. So 720 such possibilities there. Such a 3-digit numbers without repeating the number lock can form. Okay. Any clarification? Find the number of arrangement of letters of the word algebra without altering the relative position of the vowels. and the consonants. Okay, without altering the relative position of the vowels and the consonants. So in the given one algebra, that words A, E, A, three vowels are there, A, E, A. So in the A, E, A, those position should not be there. Similarly for consonants also. That means first position vowel, then fourth position vowel, then last position vowel. In that you should not change. That's what the condition is given. Similarly for consonants. So if you fix it vowels in those places, automatically the consonants place also fixed. Okay, there will not be change in that relative position. So in that manner, we have to find the permutation. So there are 7 letters. Without condition, we can do picking all that and arrange it without meaning. 7 factorial ways we can do. But here we go for 2 A's are there and rest all different. The vowels A, E occupy first and fourth and seventh places. A, E. All vowels. Okay, 3 vowels are there. That should be occupied first place, fourth place, seventh place. The number of which they can be arranged in 3 factorial divided by 2 factorial. So how many vowels are there? 3 vowels. So 3 factorial ways they can arrange it. Okay, 3 factorial ways you can arrange it themselves, vowels themselves. But in that, 2 vowels are same. So repeated elements, repeated object is that should be divided. So that is 2. So 2 factorial should be divided. So hence you will get value 3. So only 3 ways you can arrange it, those 3 vowels in the first, fourth, seventh place. First one A, E. Okay. Next one A, E, A. Second one. Next E, A. That's it. No other possibility. Once again, first what is that? Permutation A, E. So that means first position A, fourth position A, then seventh position A. Sorry, E. That is the first arrangement. Next arrangement A, E, A. A, E, A. Okay, that means A first, E fourth, A seventh. That is the second arrangement. Next E, A. So that means E first, A fourth, A seventh position. In that only you can arrange. That is 3 we are getting. Remaining we have 4 consonants. All are distinct. Okay, all are distinct. I mean different. So the number of ways they can arrange themselves, that is 4 factorial ways. So since each way arranging the vowels can be associated with each ways of arranging consonants, so that is 3 into 4 factorial. Okay, the arrangements may differ. So that is a 4 consonant arrange themselves, 4 consonant arrange themselves in 4 factorial way. So the 4 factorial is 24, so total is 72. Okay. So that second place, third place, then fifth and the sixth place. Okay. So the arrangement, okay, arrangement of the consonants also affect the calculation. I mean the permutation will come. That's why we multiply these two vowels arrangement themselves, consonant arrangement themselves. Both we are multiplying. So that is 3 into 4 factorial. That is equal to 72 will get. Any question? Okay, so circular permutation. So here we are getting circular permutation. There are 5 gentlemen and 4 ladies to dine at a round table. In how many ways can they seat themselves so that no 2 ladies are together? Okay, with restriction. So previously we had seen the circular permutation. Circular permutation, what is that? N minus 1 factorial power. So without any condition, arrange in the circular table, the permutation is n minus 1 factorial. If clockwise, anti-clockwise, not consider as the different thing, that is n by 2. I mean 1 by 2 into n minus 1 factorial. 1 by 2 into n minus 1 factorial. Okay. So, but here one more condition is given. So here, what is that? No two ladies sit together. So total person 5 plus 4, 9. Without any condition, we can M2, M3, M4, M5. So that means M1, M2. See the diagram. M1, M2, M3 are denote the male. I mean gentleman. M1, M2, M3, M4, M5. So 5 gentlemen in that place you can occupy. Then only you can arrange no two ladies together. So in that the X mentioned that seats can be allocated for ladies. So in that we have totally 5 places are there. 5 places. Okay, in between gentlemen. So then only you can arrange no two ladies together. So out of 5 places, you can arrange out of those 4 X places, you can arrange the ladies. So in the round table, first we have to concentrate on the gentlemen without any restriction. In the M1, M2, M3, M4, M5, they are in the circular circle permutation. So for that, the permutation is 5 minus 1 factorial. So that is 4 factorial, 24 different ways you can arrange. So now the remaining X place should be considered like ordinary permutation, like an ordinary permutation. That means, what is it? 5 places P4. I mean, yeah, we have only 4 ladies. So that is out of 5 places, 4 places only at a time occupied. So here they have mentioned, not mentioned, what is that? They can be seated. I mean, 2 gentlemen can be seated together. But only condition, no two ladies are together. So hence, out of 5 places, 4 ladies occupied. For that permutation is 5P4. 5P4. Okay, that formulation is what is that formula? NPR is equal to n factorial divided by n minus r factorial. So that is 5 factorial divided by 5 minus 4 factorial. So that is 5 minus 4 is 1. That's why 1 factorial they are putting. So that is 5 factorial value is 120. So this 120 into 24. So 120 into 24. That number of ways they can be seated in the round table. Okay, next. So what will be the value number 120 into 24? Answer B. So that is 2880, 2880. Okay. In how many different ways can the letter of the word Allahabad be permuted? Permutation. Okay, that means arrange. That is the meaning. That is without meaning. Okay, here I have to take it up without meaning. So the word Allahabad has 9 letters in all. Here, though, no restriction. So mostly they will add up something like alphabet. Consonants, vowels. All vowels are together. All vowels never together. Such a way that you have to permutate. Like that, they can add up the condition. But in the problem, they are not added. So you have to be very clear. This kind of letters. That means Allahabad, algebra. What is that? Letters, ways, permutation. Take it up those words in that. Arrange the word, arrange the letter in different combination, different permutation. Take all letters, otherwise take some particular letters. Okay, so that case, what is that? If all vowels are not together, all consonants are not together. If all vowels are coming together, wherever in the arrangements they have to be together. So like that, they add up. Okay, those conditions you have to add up in the question. Okay, so when they add up, I mean, if they have asked, you have to take that how to apply the permutation. So here, no such things that have make it. So take it up all the letters and arrange it. That's it. Okay, no restriction, no restriction. But letters, some of the letters are repeated. So that is A repeated 4 times and L repeated twice. Other letters are only once. Okay. So total number of letters in the word Allahabad, 9 letters. In that, 4 A's are coming. So for repeated letters, I mean repeated objects, that should be divided. So that is 9 factorial divided by 4 factorial into 2 factorial. The 2 factorial is nothing but L. L occurs twice. So hence divided by 2 factorial. So that the remaining letters coming once, not a matter. Okay, that you can omit only the repeated letters. You have to take it up. So hence the value 9 into 8 into 7 into 6 into 5 into 4 factorial. 9 factorial means that calculation 9 into 8 into 7 into 6 into 5 into 4 factorial. So the 4 factorial is there in the denominator. You can eliminate 4 factorial into 4 factorial. So the value of 2 factorial is 2 into 1. So anyway, the value is 2. So that can be reduced in the 6, they reduce it. So let's simply multiply 9 into 8 into 7 into 3 into 5. You'll get 7,560. Any clarification? Yes, next one. In an examination hall, there are 4 rows of chairs. Each row has 8 chairs, one behind the other. There are 2 classes sitting for the examination with 16 students in each class. It is desired that in each row all students belong to the same class and that no 2 adjacent rows are allotted to the same class. No 2 adjacent rows are allotted to the same class. In how many ways can these 32 students be seated? Okay, how many different ways can these 32 students be seated? So the permutation is in this problem. Understand properly. We have 4 rows of chairs with 8 chairs. In the 4 rows, 8 chairs are available, and we have 16 students in 2 classes. Okay, 2 class. So class A, class B. Class A, 16 students. Class B, 16 students. When you arrange the what is that seating, no 2 rows, having same class students, but behind you can be allocated the same class students. That's what they try to say. So for that, how many different ways we can arrange? So here, first, so no 2 rows. Okay, how many different ways you can arrange? Row 1, row 2, row 3, row 4. So class 1, class 2. So that is class 1 can be arranged 1, 3 or 2, 4. Okay, that is 2 different ways you can arrange. Okay, once again, class A, class B. Okay, 2 classes are there. If you take it up class A for 1 and 3, automatically 2 and 4 allocated for class B. So there, the 2 classes are not together. I mean, 2 rows are not together. Okay, same class students are not together. So that is one way. Otherwise, class A for 2 and 4, class B for 1 and 3. So that is another one. Okay, only 2 possible ways you can arrange the classes. So that is 2 first. Next, therefore, one class can be seated in the 1, 3 or in 2 and 4. That is in 2 ways. Now 16 students of this class can be arranged in 16 chairs. Okay, 1 and 3. Okay, 1 and 3 for class A, for example. Okay, so 1 and 3 is for class A. So total 16 chairs are there. You can allocate 16 factorial ways. So here no roll number, no register number, any different orders, any different order way you can arrange. So this is permutation arrangements. Careful. So hence those 16 first class 16 students can be arranged in first row and the third row. 16 factorial ways you can arrange. Okay, so if you want, you can give the name to the students, and one by one, you can check for the different arrangements. Similarly, for the class 2, for class 2 students, total strength is here 16. So that can be allocated for 2 and 4. Okay, second row and the fourth row, 16 factorial ways you can allocate. Okay, because we have 16 places. Okay, so that is they have mentioned 16. That is nothing but 16 factorial. MPN is equal to n factorial. Okay, that is nothing but what is that? NPN is equal to n factorial divided by n minus n factorial. So as I said earlier, 0 factorial is what? 1. Okay, that's why we are getting 16p16 as a 16 factorial. So hence you will get total number of what is it, permutation or arrangement of these 32 students with the given condition equal to 2 into 16 factorial into 16 factorial base. We can arrange it. So 2 into 16 factorial into 16 factorial. That is the answer for this question with a condition. The condition vary, you will get a different arrangement. Okay. The condition is different, you will get a different permutation. Permutation means arrangement. You will get. Okay. Any question? Yes. In how many ways can a student choose a program of 5 courses or 9 courses are available and 2 courses are compulsory for every student? Okay, this everyone will face here in the university. There are a lot of what is that, choice course, but it is not restricted by our student. I mean, some of the courses restricted by the department. Okay, Yeniko, we have total 9 courses. Total 9 courses or 9 subjects are available. In the two, I mean, we have to select 5 courses. 5 courses for the particular semester. Okay, for example, in this what is it, 6th semester, fifth semester. Okay, 5th semester, you have 9 courses available. In that, you have to choose 5 courses. Okay, 5 courses. In the 5 courses, out of 9 courses, 2 courses are compulsory. 2 courses are compulsory. You have to take it. So that omit it. Remaining 3 courses, we have to choose from the remaining 7 courses. So total available courses 9, and we have to choose 5 courses. In that, condition is 2 courses compulsory, 2 particular courses compulsory. You have to choose it. Okay, if it is for the what is it, second semester, for example, something some technical English and mathematics are compulsory papers. Remaining you can choose. Remaining 3 courses out of 7 courses you can choose. For example, I'm telling. So, but technical English and mathematics compulsory. Other courses, other available courses 7. In the 7 courses, you can choose 3 courses. Like that, you may get the option. How many different ways you can choose? Okay, how many different ways you can choose the courses. So now 2 courses compulsorily we have to choose it. That is only one way you can choose those 2 compulsory courses. So you have to omit it. So out of 9, 2 courses omitted compulsory in each selection should come. So that is one way you have to choose those 2 compulsory courses. So in the remaining 7 courses, you have to choose 3 courses. So that is 7-3. Okay, that is 7C3 ways you can. I mean combination concept. 7C3, otherwise C of 7, 3 different ways you can choose the courses. So that is 7 factorial divided by 3 factorial into 7 minus 3 factorial. So formula for combination NCR, otherwise C of 7 comma 3. That is n factorial divided by r factorial into n minus r factorial. So using that formula and simplify, you will get 35 ways. Okay. So the compulsory courses, only one way you can choose. So 1 into this 35. So 35 different ways you can choose with this condition, with this condition, only one condition, not more. That is two compulsory courses, compulsorily you have to choose. This permutation and combinations are important concept. We will use it in the probability also. If you are too clear in the permutation and combination concept, these formulas applicable in the probability also. Okay, we'll move on to the probability concept. We solved so many problems. Some of the problems you have studied in the what is it? You can refer the Agarwal book, R.S. Agarwal aptitude book, and other books and other questions also are available in the net. Okay, so booksc.org. In that website also you can download more aptitude books. booksc.org. In that website also you can download some of the books. Okay, some of the websites are available. You can download the aptitude questions. You can download and use it. With solution it is given. Okay. So now probability concept. These probability concepts are very simple. So probability of A, number of cases favorable to the event divided by number of possible outcomes. The mathematical concept of the probability of the event is equal to number of cases favorable to the cases divided by number of possible outcomes. So here mostly most of the problems are asked based on the cards and what is it, tie, coin based problem. So what is the probability of drawing a king from a well shuffled deck of cards? Okay, what is the probability that drawing king from a well shuffled deck of 52 cards? Okay, so how many different, what will be the probability? So a pack of cards means 42 cards. Okay, in the 52 cards. In that, how many kings will be there? 4 kings. 4 different cards are there. 2 red cards, 2 types of red cards, and 2 types of black cards. Pad, clever, 14, diamond. So the hearting and diamond red cards, remaining to spade and clever or black cards. Okay, so the cards are very basic things in the probability we'll use. So on an operation which can be produce same some well-defined outcome. Okay, so what kind of event you can use the probability? It should be a well-defined outcome. So you should give the well-defined outcome. So as I said, the coin throw, a fair coin throw event, a die throw event, a single die or 2 die throw event. Die means cube with 6 surfaces. 6 surfaces. This card, pack of cards, all will come under the experiment. An experiment which all possible outcomes be predicted in advance is called the random experiment. So we can identify these are the possible outcomes, but exactly we cannot say this one is going to be the outcome. Okay, exactly. And till some of the times, what is it? We can achieve. So something, it's like a gambling. Okay, throw a coin. All the time you cannot expect as a head. Throw a single coin. All the time you cannot expect as a head. If you get it all the time head, that is not a fair coin. So you cannot take up for the random experiment, those kind of events. So that's what they have mentioned. Rolling a unbiased dice, tossing a fair coin, drawing a card from the well shuffled cards, picking a ball from certain color from the bag of containing balls of different colors. Okay, bag containing different color balls, picking balls randomly. Okay, so this kind of events can be coming under the random experiment. For that only you can apply the probability. So here some of the inputs given. A pack of cards contain 22 cards. Okay, this is all well-known concept. 4 types of cards: spades, clubs, hearts, and diamonds. In that, black cards are spades and clubs. Hearts and diamonds are red cards. totally face cards. So they will mention it as a face cards. 4 face cards are there. Okay, that is yes, A. That card also under the here face cards. So total 4 cards. Yes, king, queen, jack. Okay, jack, king, queen. These 3 plus yes also will come under the face cards. So in the question, a face means 4 face cards for each type. Okay, 4 types of cards. That is pairs, clubs, hearts, and diamonds. So that manner it will be there. Sample space. When we perform an experiment, then yes, will be the sample space. Set up a possible outcome of the event, random experiment. That's it. You all know that the sample space, this probability concept you studied in the 4th semester. So just we recollect the concept, then we move on to the problem. Example of sample space, when you throw a single coin event, sample space S will be H and T. When you throw a 2 coin, that will be the, I mean, H, 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 T, T, H, T, T. Next, throw a single dice, you will get 1, 2, 3, 4, 5, 6 will be the outcome, is the sample space. If you throw a 2 dice, total 36 sample points will come. S equal to 1, 1, 1, 2, and so on, 6, 6. Total 36 sample points will be there in the sample space when you throw a 2 dice. Next, event. Any subspace of the subset of the sample space is called the event. Okay, any subset of the sample space. Some particular condition we can reduce it. What is it? In the single throwing coin, you can take it up getting head as our event. So in the 2 coins, you can define our event is getting 2 head. Otherwise, at least 1 head as an event you can define. Okay, getting at least 1 head is our event. For that, the probability will be 3 by 4. 3 at least 1 head. The favorable event is 1. The first 3 things will come favor to the event. So 3 by 4. Total sample points are 4. So like that we can make it. So probability of occurrence of the event, the probability, the particular event probability of E is equal to N of E divided by N of S. Number of sample points in the denominator, number of favorable, how many numbers, and the conditions very important. Results of the probability. So probability of sample space is always equal to 1, and the probability of any event value lies between 0 to 1. Very important. Probability of any event lies between 0 to 1, not more than 1, and no negative value. Keep it in mind. Probability of null event is also equal to 0. So if 2 events happening, okay, so in the 2 events, probability, how come you apply set theory concept? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. If 2 events in that it may having common sample points, for that the probability will be probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. So probability of A means the what is it, for the event probability, favorable cases divided by sample space. P of B is equal to N of B divided by N of S. From the N of P of A intersect B is equal to N of A intersect B, number of elements common in the event A and B. That number of elements will come in the numerator and sample space, total number of sample points. A bar denote the complement of the event A. If you define single die, getting odd number, okay, getting odd number is the event, means 135 will be the sample point. The A bar is nothing but corresponding complement. So 135 will come the event for A sample point. For A complement will be 246. I mean even number. Like that you can understand the complement. A simultaneous throw of pair of dice, find the probability of getting total more than 7. Getting more than 7. So 2 dice we are throwing. So total possibilities we all know that 36. That means 1, 1, 1, 2, 1, 3, and so on 1, 6. Second row, that is 2, 1, 2, 2, and so on 2, 5, and so on. Last one 6, 6. In that, when you add up these two phase values, we have to get more than 7. Okay, more than 7. What are the phases? Okay, yeah, what are the sample points satisfy more than 7? Okay, strictly more than 7, not equal to 7. Okay, more than 7. That means 8, 9, and so on. So that sample points, see that only these sample points 2, 6, 3, 5. Okay, the first row 1, 6 will not get. In the second row you will get 2, 6. Okay, 2, 5 equal to 7, so you will not come. Second row you will get 2, 6. Third row 2 elements will come. Fourth row 4 elements. Fifth row 5 elements. Like that you can write. So number of elements travel to that case. 15 such elements are there. So you can check those sample points. Okay, 2, 6, 3, 5, 3, 6, 4, 4, 4, 5, 4, 6, 5, 3, 5, 4, 5, 5, 5, 6, 8, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total 15 sample points are traveled to that. So that is 5 by 12. And, next, a bag contains 6 white ball and 4 black balls. 2 balls are drawn at random. Find the probability that they are of same color. So n of s is equal to 6 plus 4. So total number of balls. So we are picking 2 balls at random. So that is 10C2. So how many different same color? Okay, same color they are asking. So without any restriction, we are picking the balls. So that is 10C2 combination way. 10C2 combination way, you can pick that. So that is 10 in 10 factorial divided by 10 minus 2 factorial into 2 factorial. So simplify, you will get in that simple manner. That is 45. You will get it. So in that, our condition is what? 2 balls are drawn at random. Find the probability that they are of same color. Whatever we pick, that is same color. That means 6C2 and plus 4C2. So 2 white balls. Okay, picking 2 white balls. How many different ways you can choose? There are 6C2 ways you can choose. Another one 4C2 ways you can choose. So in between plus. So that is value 21 you will get. 6 into 5 divided by 2 into 1 plus 4 into 3 divided by 2 into 1. The 2 different ways you can choose. Okay, picking those 2 balls. 2 different ways you can do. That is, picking those 2 balls are white. What is the probability? That is 64. Picking 2 balls are can be black. So that is another possibility. There you have to use the sum rule, summation rule. So that is 21. So that is 21 divided by 45 is the answer. So that is n of e. So without any restriction, 10C2. That is 45 different ways we can pick 2 balls. Next, based on this condition, I mean that is the event. The event is what? Picking balls are same color. They didn't mention specifically picking 2 balls are white. Okay, so both cases you have to take that. So that is 62 ways you can pick 2 balls as a white. 4C2 ways you can pick the picking 2 balls are black balls. So like that you can pick it. So both values you have to add up. So this number of ways we can select. In how many ways can 10 postcards can be posted into 6 letter box? It's actually permutation, so that is 6 power 10 number of ways. There are balls drawn at random from a bag containing 6 white, 5 green, and 4 balls. What is the probability that the balls are different colors? 3 balls are drawn at random. Okay, 3 balls, 3 different types of 3 different colors of balls are available. And here, what will be the probability? Without any restriction, picking 3 balls. That is the sample space. That will come in the denominator. That is nothing but 15C3. 15C3. 15C3 as a denominator. And the numerator, each type 1 balls we have to pick. That is white, 6 white. From 6 white we have to pick 1. From 5 green pick 1. Next from 4 red pick 1. That is 4C1 different days, 5C1, 6C1. Those values will come in the numerator. Simplifying these things, we will get the value 24 by 91. Thank you. Any doubts you may discuss with me, others may leave. Okay. We wouldn't solve much problem in the probability area, but anyhow, you all well aware of the probability concept. Mostly depend upon combination and permutation. Your probability and queuing theory or probability and statistics. Those who are clear in that topic, you can solve the probability problem. It's not a big issue. Thank you all. Any doubt you can discuss with me.
Thank you, sir.
Thank you.